This is the first in a series of videos on correlation. And correlation has to do with when you're looking at the relationship between two variables. And usually when you're looking at a relationship between two variables, you distinguish between what's called a response variable and an explanatory variable. Now, these go by a lot of different names. Response variable is often the outcome of some experiment or some process. So sometimes it's called the outcome or the outcome variable. It's often known more formally as the dependent variable. And this is the most precise term, so this is the one that is used in more advanced usage. And oftentimes we just think that it's the y variable. Now, if you think about back to high school math, we think about often terms in times of functions. Y is a function of x, where x is the input and y is the output. And it's the same type of reasoning here. Here, the response variable is the result, and the input is what explains what happens. So the explanatory variable often is called the input variable. It's also sometimes called the independent variable. This is often used in more formal terms. It's also, if we think about it in terms of experiments, it's called a factor or an explanatory factor. And oftentimes we just call it the x variable. So this very much, just think about this as the way you've studied math before. Y is determined by the values of x's. X is the input and y is the output. The one exception is that though in statistics we almost always have a single response variable, in almost all advanced cases we have many explanatory variables. So even though in the simple examples we'll talk about one x variable and one y variable, in the real world we have many, many different explanatory variables or x variables. Well, there's many ways to look at the relationship between two variables, but the most common is what's called a scatter plot. And a scatter plot can be used in situations where there's a formal distinction between the response variable and the explanatory variable, but it can also be used more generally for any two variables. And if you think of a scatter plot, you simply have two variables here. In this case, we can call this the x and the y. And then a single point on a scatter plot simply is an observation or individual and explains the x value and the y value for that particular individual. So a scatter plot might look something like this. And if we take a single point here, this gives you a given value of x and a given value of y for that one observation. A simple case, let's say that you looked at all of your classes and you looked at the tests. And let's say you took an entire high school career, and for every final you look at the hours you spent studying and your grade, your percentage score on the test. Now, there would be a relationship here, but it wouldn't be a perfect relationship. Some tests you wouldn't study very much and you still get a pretty high grade, whereas others you wouldn't study very much at all and you get a low grade. If we plotted all of those values, so let's say, for example, this one right here, let's say here you spent, for this final, in the 2 weeks before the final, let's say you spent 1.5 hours studying, and your percentage grades was a 72%. That would be that value right there. And then if you look here at the different values, that would give you a general relationship between the percentage score and the hours studied, and that's called a scatter plot. And scatter plots are easily done. Graphing calculators do it. Obviously, all computers would be able to do that. Now, an important issue on a scatter plot is what's called an outlier. So we want to think about what is an outlier. Literally, an outlier is a value that outlies. So if we think about that, let's look at a scatter plot. Here's again our x values and y values. Let's say there's a general relationship here, and there was one value that was far away from the others, right? So here's a general range of x and y values, and this is very different. That's what an outlier is. Let's look at a specific example. Let's say you were studying the NFL, and on this variable were the wins that a team had in a given season. And here would be the number of fumbles that a team made, and for each team you plotted the two. And if you plotted all of those, you might see a general relationship in the sense that the more fumbles a team has, the fewer wins they have. The fewer fumbles, the more wins they had. This might be an example of an outlier. An outlier might be a team that had many fumbles, but also had many wins, right? So maybe they won 15 games, but they had a lot of fumbles. Let's say in the course of the game, maybe they had 35 or 40 fumbles, right? So do you see that there's a general relationship here, and there's one individual observation that lies outside of the normal relationship? That's called an outlier. And that's the general idea of a scatter plot. The key things to the scatter plot is make sure that you label your axes. And the second thing to remember about a scatter plot is even though there might be an input and output variable, there doesn't have to be. So the next video talks about correlation, and we'll pick up in the video 2.